Hello everyone. Today we are going to start with our new data structure stack, and it is a very important data structure. You will see questions related to stack in almost every OA interview, in almost every OA round, in every coding interview. We don't get the questions of stack directly, but yeah, they are related, like they are combined with some topics, and we get questions of that. And the most important type of questions of stack, or if I say that the only type, like which comes in exam, is a monotonic stack, which we are going to discuss in our coming lectures. And this is like very important topic. And if you talk of stack, you most like 90% time you will talk of monotonic stack. So let's like see what we are going to learn in this entire playlist. We are going to first of all see the stack, the basic syntax of stack. Then we will start with monotonic stack. And once we start with monotonic stack, we are going to learn the basic syntax of monotonic stack, like how to identify the questions of those type, how to write down the codes. We will see some standard problems. Like once you solve those problems, you get acquainted to the concept of monotonic stack, and then you can solve the questions related to this. And we will then practice some really interesting questions, which will help you to grind the topic well. Yeah, so that's all we are going to do with the playlist. Today, we are going to see some basic syntax of stack, after which we can start with the monotonic stack. Okay, so first of all, let's see what stack brings to us in the table. Let's suppose you have an stack is something which we called as last in and first out. If you want to visualize it well, let's suppose this is a stack. We have something like this. Okay. Let's suppose you enter number one in your data structure. That is, you insert the number one. So one first of all will come over here. Let's suppose then you perform an insert operation with number two, then two will come over here. Then you perform insert with number three, then three will come over here. And let's suppose you perform a pop operation. That is, you delete the element. So you can't delete any like the element you want. If you delete an element, it will always be deleted from the top. That is why we say it last in, first out. Last in, first out. Okay. So this is what the data structure stack brings to us in the table. Last in, that is जो सबसे बाद में आया, first out, वही सबसे पहले निकलेगा. That is, we brought three at the end, so it will be deleted at the first with the highest priority. So once we perform an pop operation, it will delete the topmost element. Just keep it in mind, it will delete the topmost element and not any random element that you want. Okay. So, okay, you will delete 3. Okay, so let's suppose you insert 4. So now, once 3 is deleted, 4 inserted at the top of 2, and it is also the topmost element. So once you call for the top element of the stack, it will bring you the number 4. Okay. So this is how we can perform an insertion deletion. We will see the syntax, like we have some inbuilt functions which we can use to find out this topmost element for inserting the elements in the stack and all. We will see them in the coming lectures. But for now, just try to understand that what operations we can perform with the stack. The first thing and one of the most important thing that you need to keep it in your mind is that the stack is a data structure which allows us to just perform operations last in and first out. You can't delete any random element. You if you perform an operation of deletion, you can only just delete the topmost element. And even if you just want to see the elements you have inserted in the stack, you just can't go and look to each and every element. You can only get a look at the top element of the stack and nothing more. Okay. So yeah, this is a data structure stack. It's very useful. Let's suppose you want to perform an insertion in the stack. Let's see the time complexity of insertion, deletion, and searching. If you want to talk of insertion, So just tell me the time complexity of insertion. What you will do? You will just insert it at the topmost position of the stack. So the time complexity of insertion is nothing but big of 1. That's the constant time. If you talk of time complexity of deletion, so if you talk of time complexity of deletion, then you will only delete the topmost element of the stack and you can't delete any random element. Yeah, that's the constant, but what's the time complexity? It's a constant time, isn't it? Okay. So let's see the time complexity of searching in the stack. Can you perform binary search over here? No, na, you can't perform binary search because for binary search to be performed, you need to get access of the middle element. But over here, you have the access only of the topmost element, isn't it? So you can't perform binary search over here. You need to perform the linear search. And what's the time complexity of that? If you see, we have like for finding, we need to delete the topmost element every time we don't get the required element till the stack is not empty. So yeah, the worst case time complexity in this case, like for searching, will be big of n. And what type of searching is this? It is a linear search. So yeah, this is the time complexity of insertion, deletion, and searching. So you can see that insertion and deletion are very fast in case of stack. So once see if you find questions like this where you need to insert and delete in some specific order, then and in constant amount of time, then yeah, you can look upon to stack and just ask for help from stack. Okay. So we will keep the till now in this video. We will see the basic syntax and one practice question for stack before moving to the topic monotonic stack. By then, thank you.